Well, in this manuscript, you are going to discuss about this manuscript. The link for the manuscript was provided in the video description. The spreadsheet that you use in this video was provided in the description of the playlist. Well, in this manuscript, the authors described the antioxidant activity index. Well, normally the tests for total antioxidant capacity were carried out using this molecule that is normally known as DPPH. But this test changes according to the concentration of the free radical molecule. And this new index proposed by the authors is unchanged according with the concentration of the free radical molecule. So they have determined the inhibition at three different concentrations that you can see in the manuscript. They did it in three different concentrations. As you can see, as the concentrations increase, the normal index also increases. But this new index proposed by the authors weren't changed according with the concentration of the free radical molecule. So in this video, we are going to analyze this data set. Well, you can go to JAMOVI, you can go to Open, and we're going to work with this data set. This data set was provided with this name. Well, the data is in here. As you can see, when the radical molecule concentration decrease, the index also decreases. It is highly dependent from the concentration of the radical molecule. Well, the first question that we're going to answer is if the results obtained using different concentrations of the radical molecule were different. So we can compare these three paired variables. We can compare these three paired variables. We go to ANOVA menu, and they go to repeated measure ANOVA. We must remember that repeated measure ANOVA is used for dependent variables, while ANOVA was used for independent variables. So we go to here. We are going to type the description of hash paired variables. So we type in here. And the description, we are comparing concentrations. We are comparing the index determined using different concentrations of the free radical molecule. So now we are going to add the variables, and the software are going to calculate the p-value. According to the p-value, you can see that the concentrations, the index obtained using different concentrations of the radical molecule were different. But you cannot see where there is the difference. We can go in the sequence and go to assumption checks. The first thing that we look for is for sphericity. According with the Macaulay's test, we can see that sphericity was not found. When sphericity was not found, we can use to choose correction factors. For example, I can reduce were repeated measure of using correction factors. The correction factors were applied and the results remains the same. The index found using different concentrations of the free radical were different. The second thing that we're going to do is to check for data normality using a key plot. Looking to the key plot, we can see that the data deviates from the normality. So at this point, we can see that a better choice to analyze this data set is the non-parametric Friedman test. And we can look for specific differences between the pairs using post-hoc tests. So I am going to check and use the post-hoc tests. The post-hoc tests have used the 2K test. The post-hoc tests have shown that the index found in using the 3 different concentrations are totally different. So we're going to see the marginal means and place it in here. The descriptive plots shown by the software clearly shows that the index found using different concentrations of the free radical molecule dramatically changes according with the concentration. We can see that the higher concentrations of the free radical molecule led to higher index. So we can see that the results obtained with the 3 different concentrations were totally different. Well, we can use now the non-parametric tests, the Friedman test. We go to here to Friedman test, and they're going to select these 3. The Friedman test provided the same result as the parametric test. The Friedman test is non-parametric test, and it provides the same conclusion that we obtained using the parametric tests. I can also use a non-parametric post-hoc test, the Durbin-Conover test, and we can see that the results obtained different concentrations of the free radical molecule are totally different. So in this situation, we can see that the best choice is the non-parametric test because this parasite was not found and because the data was not normally distributed. But both tests provided the same results. Why both tests provided the same results? Well, in this situation, as I can see here, the results obtained are very different. We can see that the means obtained with the 3 different concentrations of the radical carbon molecule, the free radical molecule, are very different. We can see that it is very different. In these situations where the numerical difference is very different, both tests can provide similar results. However, when we get back and we look to antioxidant index described by the authors in this manuscript, the authors described in the manuscript that this index is unchanged with the concentration of the free radical molecule. If we're going to descriptive statistics and make a basic statistics of this index proposed to the authors, and the authors say that this index is unchanged with the concentration of the free radical molecule. If we're going to do that, we see that the index obtained using 3 different concentrations of the free radical molecule are very close. As you can see, it is very close. We might add this 3, 2, and you can see that this index was this 3 index has a large numerical difference, but this other 3 don't have a large numerical difference. There are numerical values that is very close. So in this situation, the choice of the tests might dramatically affect the results which you can get. For example, we are going to repeated measure of, we are going to here. Once again, we are going to type the description of the variables that will be compared. For example, I just will type the concentrations. And we go into add the variables which I'm going to compare. I select and add the variables. The repeated measure of shows to me that the results obtained using different concentrations of the free radical molecule were also very different. We have a very small p-value in here. Well, in this sequence, we can go to assumption checks, and we're going to look for the disparity tests. Well, in this situation, the Macaulay's test said that disparity was found, and we go to the key plot to check for data normality, and we see some deviations for the normality. Well, we can also look for a specific difference using post-hoc tests, and the post-hoc test said that there is a dramatic difference between the index found using this concentration and this concentration. But there is no appreciable difference between the index found using these concentrations. Well, at this moment, science we see some deviation from the normality. We might also thus the non-parametric test. We are going to the Friedman test, and we are going to add these three variables, and we get a p-value that is smaller than 0.005, but is much bigger than the p-value obtained using the parametric test. So we can look for a specific difference between the pairs using a non-parametric post-hoc test, that is the Durbin-Conover post-hoc test. As you can see here, the post-hoc test said that we have the three concentrations, a high, a middle, and a lower concentration. The non-parametric post-hoc test said that the index found using the higher concentration is identical to the index found using the other two concentrations, but it found a difference between this concentration and this concentration, as we have shown in using the non-parametric post-hoc test. So we have also some close results, the parametric and non-parametric post-hoc tests. It was interesting because we have small differences. We have small differences between this numerical. We have a numerical difference that is very small between these tests. But the hypothesis tests say that these values were not equivalent, were not statistical equivalent. So this is a manner that you have to compare paired variables. If, for example, we want to see if a factor might affect your tests when you have paired variables, you might use the repeated measure ANOVA as a parametric test and the Friedman test as a non-parametric test. As you can see, the results obtained using the parametric and non-parametric tests were really close. The biggest difference between the index proposed by the authors was in these two concentrations, as shown by the non-parametric post-hoc tests, the Durbin-Conover post-hoc test, and by the 2K test. I expect that you appreciated this video, and we are going to the next video of your playlist.